So I'm just going to talk about today taking the structure a little bit further and showing you some shortcuts and so on as to how you get all the stuff working up quickly and easily, because Revit is supposed to make your life easier. It's not supposed to be make your life more difficult. No, I just made that just now, actually, in the other class. But this is just the standard model. I just made a very quick house. Just made a rectangle, put in some internal walls, just threw in some windows, and put a roof on it. So it's just a very simple model. I don't want to do it again because it's just a box, basically, and it's only just to have a starting point for what I'm going to do. But if you want to, you can use the project you're working on now. You could save a copy of it, and you could use that because it's the same process as to what I'm going to talk about. But did everybody download this extension here, the timber framing extension? Yeah. Okay. So I'm going to talk about how that works and how and what its failures are, because actually it's not a great piece of software. It's only a starting point for because it's made for the American market, and the American market is usually the timber frame in the walls is pretty much the entire depth of the wall, because they don't like to use insulation. They prefer to burn lots of oil instead. So they make their walls very, very thin. But for European walls, which are twice, 3 times as thick, the timber framing extension is not specifically it doesn't really work that well. So if you're using it, you need to first of all understand that this is the case, and you might need to make a copy of your model with a thin wall, like an American wall, in the right position. It would make more sense if they remade it so that it built the timber frame inside the structural layer of the wall. I thought that's what they were going to do with the new version, but they haven't got around to that yet. So they just basically follow the line of the wall, and they build the timber frame, and they don't take into account insulation or cladding or anything like that. So if you're going to use it, you should really make link your architectural model into a separate file, and then make another model with very thin walls that relate to American walls, and it might help you. It's only one method of doing it. But just to show you how easy it is, if I go and I'm going to select, let's just switch off this section box. I'm going to draw a window around this simple box house I've just made, and then I just go to Extensions, Modeling, Wood Framing Walls, and it opens up this window, and you can see that it's already pretty much looked at what kind of wood framing you would want in a house like this. But if you look at it, you can see that actually the edges, they don't work. They haven't actually joined the corners. So even though it looks really impressive to start with, and it does a lot of the basic work for you, it leaves out significant parts of the model like this. And this becomes less if you change the wall type to a thinner wall. So if I, for example, go around here and I select, using the tab button, all the external walls here, and I just change.
Did you first just pick all the walls?
Yeah, I just picked all the external walls, because the external walls here are 400 millimeters. So I'm gonna just leave the cursor over one edge of it, press the tab button so it goes and selects all the join walls, then click on it. Then I press edit type, and I'm just going to change the structure to, let's say, I don't know, 120, as if it was just being made of timber studs. And then apply that. So now the walls are 120. So it should have an effect on what on how it makes the model. So I select it again, and I can select everything now because it'll automatically filter it out, so it just selects walls. Okay. Go to Extensions, Modeling, Wood Framing Walls.
I mean, it has to know where the windows are, right?
It has to know where the windows are, yeah. So it looks at the wall, and it checks where the windows are, checks where the doors are, checks where the openings are.
I mean, that's why you need to select windows and doors.
No, but it works off the walls. So you can see that here it actually has more or less put some corners in there. They're not completely perfect, but we get a chance to play with them.
Why did you change your wall thickness to 120?
Because I'm trying to make it like an American wall, which are much thinner than European walls. Because this system is really set up for American timber framing, where there's no real insulation. on the outside of the studs. It's all internal to the studs, and it doesn't make a perfect timber frame. So it's only a starting point. It sets up a lot of the blocking for you. So we can choose individual walls in here, and we can kind of play with it. It's giving us default elements in here. It's giving us like standard 150, 400, but we can actually choose Revit families that are in here. So I could choose a column in here that's the right dimension that I already have set up in the project instead. So that's one thing. The other thing is we can change the, if I apply this to all walls, the various heights of things. So I can say number of intermediate studs. I'm going to set that to 0. And let's just see if I can remember how this works. If I set this to 600, you can see it changes the spacing of the studs within the wall. So it sets up the overall idea as to where it goes. And then I want to put in some blocking. So I'm going to say apply to all walls as well. Generate horizontal elements, and we can put that in at let's put that in at 1600, for example. So we make it very strong, or we could just need to put it in at 3.2 to put in the some horizontal elements in there. That didn't work. 3.2, and then we can change the materials to whatever we want in here. So that's kind of setting up the overall geometry of it. Then we have the option to change how it meets the corners. So this is the type of stuff that Alan talks about, probably, hopefully. You know, you can make a decision as to how the corner element is going to be set out. You can kind of play with this as well. It is one of those things that you just need to kind of play with, because it's not an entirely, and I'm going to keep saying this, it's not an entirely thought through extension to Revit. It's only a starting point for making a diagram of it. But you can do some useful things, like you can select individual openings, for example, by name, say window 2, and you can change the way that it's set up within the project. So here you can see it's got two. Well, you can't really see that on the board there, but you can see it down here where it's extreme. It's doubling up or tripling up on the number of timber studs around the opening. So you can just get it to put that in. So let's say you wanted to put extra studs at the bottom of the opening here. We can change the header to a double lintel on top, and we can change the sill to maybe a double if you're strengthening it. And we'll change the type to timber again. So we can change that, and then there's options for user-defined elements. But if I just press OK here, it generates a wood frame based on the architectural model that we have as a starting point for a series of timber framing drawings. It takes some time. It'll give you an error message because it tries to generate the parameters you've put in there all over the house, and sometimes it comes to an awkward corner. So you just say delete the ones you don't need. So then you get something that looks like that very quickly, and you can see those extra double headers for the windows have been put in there, and on the ground as well. And it's kind of dealt with the corner in a basic way. But you need to go in there and possibly adjust it. But it's an excellent starting point for making a timber frame diagram of the house. Okay, so that's the first part of it. You also need to be aware of is that it actually generates them centered on the external face of the wall. I don't know why. So there are some logical problems with this software. That if you can use the bits that are useful, as long as you take account of the bits that aren't useful, it can be helpful. But sometimes it does stupid things. Like if I was to make some suggestions for how they would write it, I would get them to generate the studs within the structural layer of the wall automatically, and then you wouldn't have any problems. But for some reason, it generates them centered on the external face of the wall. So when you're designing your guideline, you need to take that into account. So you just have to be a little bit careful about how you use it. Same problem with the roof element. If I go up here and select this roof, and I come to extensions modeling, and say we want to put in some rafters there. You can see it gives us a roof plan straight away, and it gives us spacing between them. We can change the spacing to let's say it was 900 for some reason, and it will generate the spacing for us. But it will also generate the edges of the roof. So it will do this kind of proper cut for you if you want to. So it will generate a proper cut edge to the various rafters that you want within here. Of course, I needed to make it so that there was an overhang on the roof to make that visible. But we can also do things like we can delete some of them that we don't need using this dialog here. We can change things like, let's say the ridge board at the middle here, we can change it to a supporting beam, or various different options in here. These are just things to play with, because they're not, what I would recommend is that you design your roof first before you start playing with the software, because you don't want the software to dictate what your roof looks like. But it's a good way of generating some kind of 3D images or 3D views that you can generate proper drawings out of as well. So we can add in purlins and so forth, and then press OK. And this, even though it generates the beginnings of a nice roof structure, it's got the same issue. It generates the roof structure at the very, very top plane of the roof. So if you've designed a roof here that had tiles at this level here, it's not going to generate your structure at the correct position down here. It's going to generate it at the top plane. It's completely stupid. So even though it's got a lot of information here that we can use, we need to be aware that it's putting it in the wrong place. So that's why I'm saying you need to make a guideline model that relates to exactly the position you want it to go in outside your architectural model, and that'll allow you to do it. But you see it's making stupid things there. The structure is floating above or the roof structure is floating above the wall structure and stuff like that, which is like its default position. But if I then go into visibility and graphics, and I switch off everything that's not structural, take all these down, take those down, apply. We've got a fairly complex model of the roof structure, the entire structure of the building, within a couple of clicks. So all you need to do then is go back and go through it and make sure it actually makes some kind of sense. So that's all fine and dandy, and it's nice and it looks impressive, even though it might be wrong. But what we need to do then is do some quality assurance on it. And the easy way to do quality assurance is always go back to the basics. So I go into level 1 here. You can see where the studs have been generated. Just going to delete that. And you will have done some grids. You will have set up some grids here first of all, because you just need grids. So I've set up one, and I'm just going to set up another one going this direction, right through the center of the structure. And once we set up a grid line, we can use this as a basis to make what's called a framing elevation, which is, it's basically just an elevation to allow you to design the framing in the building. So I can go into view here, and where it says elevation, I have another option down here called framing elevation. And I can go and click this, and then I can select a grid line, and you can see that it's starting to create an elevation line here facing whatever direction I want to put it in. So if I move slightly up here, it's going to be on the outside. If I select that, it's created something called elevation 1A, which I can open up. And now we have an elevation that's taken right through the framing structure that we've just created. And you can straight away see that as soon as you get this very orthogonal drawing, you get away from the 3D drawing, the flaws in the framing suddenly become completely apparent. But you should be able to go in here and add elements or remove elements, because these are just now elements within Revit. So I could come in here and I could take this stud, for example, and I could drag it down, stop it there, for example. I could copy this one across. I can continue to work on the timber structure until I get it to a level that I think makes proper sense. Once you finish working on it, you can then just use it to basically just dimension it out, so that if you're going to a carpenter, he can very quickly set up whatever he needs to do in order to build the building like that. So just be concerned with when you're dealing with these extensions that they might not be completely correct. So you always have to do your quality assurance on them in order to make sure it works. All right. Any questions about that stuff? No. I think the frustrating thing about this stuff is it seems like such a powerful thing, and it produces such an amazing looking drawing. But when you go into the detail of it, it's not correct. So it's kind of frustrating, because that looks great. You know, that's the kind of drawing that when we did it by hand, we would spend 4 days on. You know, and it would be right. But now it just does it in 2 seconds, but it's wrong. You know, so I don't know what's the best thing. But so just be aware of that and play with it a little bit. If you're going to use it, you can play with it until you get it right. But it's a question of figuring out how it generates, where it generates, and what the basis model needs to be. Okay. So that's one thing. So that's just the timber frame extensions. The other thing we have going on here, if I just switch everything else back on again, apply. Got a house here. Is if I go into level 1 and I'm going to make a beam system. Let's do it in level 2 actually for the ground level. So I go back into the structure like we did last week. I'm going to make a beam system, and I'm just going to draw where I think the beams should go. Just going to take the inside of the structure there. And I'm going to change the beam direction so it's going across the short side like this. We've got the beams going this way. And we've got a fixed spacing over here, 600, that's fine. And dimension lumber, let's leave it at that, that's fine as well. So if I apply that and accept it here, we've got now we've got the floor structure going on inside the house. Let's switch on the section box so we can see it. So now we've got floor structure in there as well. And this is fine when you're dealing with timber. It's usually some kind of rectangular section like that. But if you're dealing with concrete or something, you're more flexible in terms of the shape. So you want to be able to deal with, you want to be able to create your own beam shapes effectively if you're dealing with concrete. So I'm just going to introduce this because it leads on to something we're talking about next month, which is family design and parametrics. And I just want to introduce this because it kind of makes sense if you're dealing with it in something that's in a specific way. But let's say we wanted to make a beam, a specially shaped beam for this element here, if we're making it out of concrete or something. Whenever you're making something special in Revit, it's always a family. So we did annotation families in the intro period, which allows us to do repeating details and so on, just in 2D. But in 3D, we can actually make architectural objects. So I'm going to go ahead and make a new family. So new family. And as always, there's a template we need to use. So I'm going to use this Dan.edu. And we have one template here just for structural framing. So you always have to choose the correct template. Otherwise, it just won't work. So I'm going to use the structural framing template. Open it up. And this is giving us a plan view, a view from above of a beam that's 3 meters long to its structural points. If I go into a little 3D view here, it just looks like that. It's very simple. Let's just turn up the scale a little bit so it's easier to see. Turn the shading on. So it's just a rectangular beam. It's been given a length and it's been given a profile shape. And because it's in the beam template, we can play with it. So this is the family editor, and you can see the options at the top here are different to the ones in the usual project editor, because this is more into pure 3D modeling, because you're making objects that aren't walls or roofs or stairs or.
Sorry.
Yeah.
When I was trying to open the family type, there was nothing in the boundary proposal.
There was nothing.
No, like in the structural framing.
Okay.
concrete
Okay.
materials.
I'll have to have a look at that. I'll just finish this off first, and I'll have a look at that. So anyway, so we have this basic beam, and this is the basic timber beam shape. But all this is an extrusion. So if I go into an elevation, a left elevation, for example, it's centered on a reference level. It's got a shape, and if we go to a plan view, you can see at the reference level it's this long, and it's got a parameter that relates to how long it is. So a beam is basically a shape and a length. So all we need to do is change the shape, and the length can be what it is. So I'm just going to save it as a new beam. Save as family. Put it on the desktop. I'm going to call it beam 2i. Save. And now if I go into the left view, I should be able to select it and edit the extrusion. So I'm going to edit the extrusion, and there's the shape of the extrusion, just the usual purple lines that allow us to change the shape of it. There are certain things that are locked here, in that the width of it is set to 200 and the height of it is set to 300, which are what these reference lines are defining. I'm not going to go into that until next month, but anyway, but just to show you that as long as we stick to that to a certain degree, we can make some alterations to the shape of it. So I'm just going to go in here, I'm going to change the shape of it. We're going to make it like maybe something like that. And I'm going to trim this shape over to here. Trim this one over to here. Oops. This is what happens when things are locked. You're never sure if they're going to work or not. But anyway, let's see. Take this away. Going to unlock this. Can't unlock on that. No, it won't let me change it. Right, maybe I need to remove the parameters first. Okay, let's just try that again. Edit extrusion. Let's try and do it a little bit more simply and see if it works. The thing about families is families get really complicated very quickly. So I kind of limit how much we use them, because you don't really get a chance to do it very often. But sometimes they're very useful. I'll just try and see if I can get this one to copy. Like that. And if I break this line, I'm just trying to figure out how much it's going to allow me to do. Okay. It's allowing me to do some stuff anyway. So I've kind of changed the extrusion shape there. Now, the reason it wasn't letting me do a lot of stuff is that it has these dimensions that are locked within the beam structure. So we kind of have to get into what those parameters mean later, but I don't want to get into it right now, so I'm just going to ignore it for the moment. So I'm going to accept it, and hopefully we now get a beam that's shaped like that, which might be the case. Let's say you're making a beam that, I don't know, has cable boxes that you want to align into the beam or something. So you might get a precast beam designed that's shaped in a specific way. So once you've done that, what's it called? It's called Beam 2i. You can load it into the project. And you can see it turns up over here, Beam 2i. So like everything else, you can go in and select the same type of element, which is a beam. I'm going to select this one, select all the instances in the view, and I can change them to Beam 2i, like that. And because it's it's maintaining the same parameter in terms of length, all we're doing is changing the profile of it. You get something like that. You know, it doesn't make any sense in a timber frame, but if you're making it in concrete, it would have an effect that would be useful. So basically anything that you're doing in structures, you can modify the shape of it to whatever you want. So it's simply just the length of it, which is a parameter that's over here. And then there's the profile. So the profile is where you have to edit it. And that's pretty much it. Any questions about that? Oh. Just to give you an example of the type of drawings that you produce. This is from the third semester Revit thing I did a couple of years ago.
Which semester, sorry?
Third semester, and this is just a component drawing that comes directly from the same system I was talking about. So these are just beam systems. This is a framing elevation, and it's just tagged. So all the structural elements in there, all this text and so forth, is automatically within the system. So you just have to use a tag structural elements, and it will print the information on the drawing for you. So this drawing took about 15 minutes to make, because the information was already in the 3D model. So it's just a question of pulling out the structural plans, pulling out the framing elevations, and then making a schedule of all the structural elements here. Okay, but that's in the third semester video set if everybody wants to get into it. Okay. Now I'll shut up.